Hey, Digvijay.
Hi Manas, very good afternoon. How are you doing today?
I am fine. How about you?
I'm good. I'm good. Wonderful to see you again. This is basically Manas's second time here with us on Flutter meetups, and it's wonderful to have you here again with another one of your crazy projects that you keep doing, keep spending your time on.
Yeah,
And I'm really excited to see it firsthand myself. But as far as a quick introduction to Manas, he is of course a Flutter developer and enthusiast of sorts, if I say so myself, and he is a lot into blockchain. So I don't know what recent findings you've come across in blockchain, but I'm excited to know. But today it's all about 3D animations, and well, Manas, I think I'll let you take it away and let everybody know what you're doing.
yep. Thanks, Digvijay. That was a great introduction. Let me share my screen. Yeah. So, namaste. And hey, welcome to Principles of 3D Design in Flutter. I am Manas Pratap Thakur, a software engineer here at GeekyAnts. And this is my Twitter handle, at the Manas Pratap. And this guy right here is my Dashatar. I did introduce him to you all at the last meetup, but now he won't leave me alone. He just follows me around. If this continues for long, then I'm just going to name him. I'm going to domesticate him, I'm sure. So let's get started. Then, why would you want to build a 3D application, right? Because 3D is awesome. Let me show you what we will be doing today. This is an application, goes like this, like this. Looks cool, right? Who wouldn't want to buy something like this? If there was a metric you use to measure the sales pitch, I think this should be at the higher end, definitely. And this talk is not about me introducing something cool that I did. No, it is about seeing designs like this, right? And then having the questions answered, like how do you move forward when you see something like this? From where do you begin? How do you dissect this? That's what this talk is about. How do you move from 3D design to an application? And we'll see using that app as an example, right? Because this is very easy to do. It just looks fancy, but it is super easy to do. And the second thing is Flutter, you see, is unique when compared to other cross-platform tools in that it makes no attempt to mimic the underlying native SDK. Instead, Flutter uses its own high-performance rendering engine, Skia, to draw the widgets. So, Flutter requests a window from the underlying OS and entirely manages its own content in Skia using Diet. And this is the same approach taken by many of the gaming engines. So, you have control over everything in Flutter. And that's why you should try doing 3D in Flutter. Now, how do you do this? This design at first looks very complex, right? But if you look closely, any 3D design can be divided into two main parts, right? So first is things that you can represent using widgets. So widgets in 3D. And the second is the fancy objects, like let us call them just objects in 3D, right? So any design you could divide it into these two categories. So let's first start with convert three dimensionalizing a widgets, right? So now Flutter does not expose any 3D API, but it does provide us with a third axis, Z axis, in addition to the X and Y, and we will make use of that axis, right? So the three main widgets that we'll be using is stack, transform, and gesture detector. And you need only these three, nothing else. So stack is a very simple but very important widget for this 3D animation. It contains a list of widgets and positions them on top of the others. So stack allows developers to overlap multiple widgets into a single screen and render them from top to bottom. Now, this is very powerful. So you could literally take anything and place it anywhere in the screen. So let's see how I use this in my application. Right. So this is the stack. Here it is. And at first, so in stack we are overlapping things, right? At first we have the page background. So that is this part right here. This yeah, where my pointer is, right? That is the first layer. And then the second thing is the bike background. So this is a bike background where Royal Enfield is written. Then the third thing is bike itself, right? This bike is the third thing. Then we have the fourth bike foreground, we have bike specs and bike footer widget. So this is the bike foreground, Royal Enfield. It is actually above that, the background. And then this is the specs, and we have a nice cool thing here that is a footer, right? So this is how we use tags and we place different components on top of each other, right? Then we have transform, which is a widget that surprisingly transforms its child widget before painting. So after you have placed all the components on the screen using the stack, you'll need to build a scene, right? Like rotating things around, scaling them, translating them, and maybe also playing with their texture. So stack widget provides us with two types of constructors, single operation and default. Now, single operation constructor, as the name suggests, allows us to do only one operation at a time. Then why do we ask it, you ask? Why do we need it? Why do we use it, you ask? Because it is super simple to use, the single operation constructor. So consider this square, and if you wanted to rotate this, you just give it an angle, you give it an origin, and boom, you're done. So it will rotate around that axis. So here we have taken the right vertex, bottom right vertex, as the axis, and it rotates 45 degrees around that, right? So that's rotation. Now, if you want to scale things, you just give it a scaling factor. You again set the origin. So if the origin, here the origin is used to decide the direction in which the square will scale. So if the origin is on the bottom vertex, the whole thing will scale in the upward direction. If it is in the right vertex, it will scale everything in the left direction. So scale will scale, if it is here somewhere in the middle, it will scale everything in equally in all the directions, right? That's why we set an origin. So we have the rotate scale, and then we have the translate. So translate is used to move things around, right? You just give it an offset and that is done. There's no origin parameter here because it does not make much sense, because it is not affected by any origin. You just give it a offset, that is the difference in positions, and we are not specifying any absolute position. So it's only about the offset, right? So we have these three single constructors. Then we have something known as default constructor. And unlike the single operation constructor, this allows us to do multiple operations at once. This is made possible by using a four-dimensional matrix, that is, matrix with 4 rows and 4 columns. So to rotate an object using the default constructor, we take an identity matrix and set the values like this. And don't be scared yet. You don't have to remember this. You can always look this up. So if you want to rotate it around x-axis, you just set the degrees here, like 90 degrees, and same for y and same for z, right? And to scale, we do this. You have this matrix, and if you set the x value, you can scale in the x-axis. Similarly, y for y-axis, z for z-axis. And we have a scaling factor. So this is used to scale in all the three axes, right? So if you want the square to be 4 times bigger, so you give 1/4, that's 0.25, and it will scale it 4 times in all the directions. And then, so you see, using matrix, we have so much of control, right? Compared to the single operation constructor, we can define any axis and all those things. And then to translate using matrix, you set the x, y, and z value to move it along the x, y, and z axis, right? Now we have the secret sauce of our application, this one. So it is about depth. So if you use these three values in the matrix, right, you could set the depth. So what I mean by depth is that the thing closer to you appears bigger, and the thing that is further to you appears smaller, right? So here you see, as the Royal Enfield goes away, the D becomes a little small. And that's how we do this. We use the depth matrix. So if you control these values, You can control the depth. So depth in X, Y, and Z. Here I am controlling the depth in Z axis. That is here. So you will see many lines in, I think, some places. If you are intrigued, you will see something like set 3 comma 2 comma 0.01. So that is the third row, second column, value 0.01. So the higher the value is, the closer the end will be to you. So if you give something like 0.0001, this would be more further away, right? And yeah, so you add depth. Now let's see how we make use of this translation in our project. So let's see, translate, where are you? Yeah, here I have the single operation constructor. I have used translate. You could use something like scale and rotate also. So this is for, I'll tell you what this is being used for. You see this here, the background is being rotated, right? But as it is rotating, it is also moving in this direction. So a single translation will help me do that. I'm setting the X value to here, it goes there. Then you could use the matrix to rotate. And also remember, like, you also get this property, rotate X and Y and Z, because I think probably the Flutter guys realized that no one is going to remember the cos matrix, cos and sine. So you could also rotate like this using the this operator, rotate Y, X, and Z, right? So this was to move it in the X, and that rotate Y is rotating it in the Y direction, right? And this is the depth. So at the third row, second column, I set this value. This is what it is. And here's an extra tip for you. So you can also play around with the colors, like adding the shadow or an opacity to enhance the perspective, right? So here you see Royal Enfield, I have added an opacity. So as it moves away, the opacity decreases. It really gives it that feel. And there's a shadow on this page, right? So if you observe this, as it is going there, there's a little black shadow. So you can use opacity and shadow also to control this, add perspective, right? So we use stack to place everything. We use transform to move things around and create a scene. Then we have gesture detector. It is again a very useful thing. Yeah, it is a final piece of a puzzle. Now, you can encapsulate any widget with a gesture detector, and it will listen to gestures from that widget's layer. It provides us with these useful callbacks, that is on horizontal drag start, on horizontal drag update, and on horizontal drag end. So this on horizontal drag start comes is activated when someone touches the screen, right? And while the pointer is moving, we have this function. And when the pointer ends, we have this function with a velocity. You also have this in vertical. So you have on vertical drag start, vertical drag update, and vertical drag end. And you also have on something like on pan start. So on pan start will give you both the value, I mean directions, vertical also and horizontal also. But I needed only horizontal. So that's what I have done. And let's see how I have used this, right? Here is my gesture detector. So this is my complete screen. I have encapsulated my complete screen with a gesture detector. Here is the start function, update, and end. So what I do at start is I mark the starting position, right? And while updating this, I update the position of a variable. So in this case, I've taken the variable as animation controller dot value, but you don't need to use animation controller for this 3D design at all. You could use something like global keys, or at first what that I had done, I had used only local variables, okay? But I used animation controller now because you could just flick it and it will complete the animation. Otherwise, earlier what it used to do is if you leave it here, it would stay here. That did not make sense, right? That's why I have used animation controller, but it's not important. So yeah, coming back to gesture detector. So what I have done is the animation controller value goes from 0 to 1, and the distance, right? What I do whenever there is a drag, I I take the distance horizontal displacement and divide it by the complete screen width. So even that distance goes from 0 to 1. And that's how I map the distance with the value, right? So I calculated the distance, and then we have this, and there's an important line here. So what this will do is it will not return anything. And this is the case when you are here, right? You are swiping to the right. And once you have reached here, and if you swipe more right, there's no use, right? So that's how. So if you're swiping more right after it is activated, the specs window, then we don't do anything. Otherwise, we update the value. And same thing here. So on end, what do we do is two things, two main things, right? We have a drag function. So if a user travels more than half of the distance, and if they just leave it, the animation completes. So this is the drag part. And in swipe, what happens? If you give it a fast flick, right? Like this, it will complete. So I take the velocity here and this, okay? And yep. So a very useful widget, I must say, gesture detector. So we place the things using stack, formed a scene, and then we map the movement using the gesture detector, right? And coming to the objects, now Flutter says that they don't expose any 3D API, right? 3D optimized API. So how do we do this? You could obviously use package, right? But I did not use package because first there are a very few to none package, and if you do find one that suits your need, by using packages your speed of development would be limited to the speed of development of the package, right? So there is only as much you could do as the package allows you to. Also, control. So if a package does something in one way and you want it to be in another way, you cannot help it, right? So that's why I did not use package. But there is advantage of using package. Like you don't have to do everything. You do all the complex stuff. I mean, you get all the complex stuff and the boilerplate code out of the box, right? So I did not use package, but I used images, right? So images of 3D model. So I have many images of one model. This is good because you have more control over it, right? You have control literally over each frame of the modeling. So now how do you get this model? I mean, how do you get this image? So you get this image either from your designer, otherwise you can take a 3D design, right? So I downloaded this open source bike from Avatar. Avatar. I'll give his profile link in the description later. So I downloaded this bike and I taught myself the basics of Blender. So this is Blender 3D modeling. You could use Adobe also. So here I taught myself things like camera, anchor objects, following the path, making an animation out of it, and rendering the animation using keys, right? So you see here, the bike, what if you break down the animation, the bike goes from side to the top, right? So what I do here is I have a camera, I have a camera, and that camera goes from here, side, to the top. And this thing is your phone screen. Obviously, it is horizontal now. I flip it around when I render it. So this is how I taught myself Blender, the basics of Blender, and I rendered this animation, right, as sequence of images. And then I use the sequence of images here, right? So you can, the main thing here is we have something known as current image. This allows you to set frame for each gesture value, for each position that you are at, right? So if you go to build bike, yeah, here's build bike. So I rendered the animation in 120 fps, right? I mean, I have 120 frames images for that. So I did like this. Here for each animation value, you render a frame, right? At first I had rendered only 60 frames, so I just changed here 60 and here 60. This will work for 60, and this is quite handy. Like if you feel that this animation is slowing down, only 24 would also be enough, right? So when you render things, right, when you render a sequence of images, you get it like at 001, and all those things, right? So here you have something like you increments. So I rendered 120 images from 0 to 120, and you could and I incremented by one. So first image, second, third, fourth until 120. And you could increment it like 4, 5. So 1, 4, 8, and like those things, right? You could do like this. So here I'm just rendering a image with a transparent background. So that's all that is there. And yeah, so the closing thing was that you could, the whole code is open source, so you could either follow at Flutter BLR or the Manas Pratap to get the source code. That's it.